EnCORE features 4 solar collection technologies that help the home achieve its net zero status. These technologies include passive solar glazing, solar thermal hot water, photovoltaics, and solar thermal hot air. We start with the solar thermal hot air system. This system was designed to meet the needs of a passive house in the shoulder months and to supplement the heating system during peak loading. The solar thermal hot air collector is located on the southern wall of the home to maximize the energy potential of the system. What you see here are the 2 large solar thermal collectors. These collectors are heated by direct absorbed radiation, which transfers heat to air that passes over them. These collectors can absorb up to 16,000 British thermal units per hour at 90 to 100 degrees Fahrenheit. The system results in a 10% heating load reduction and a 9% cooling load reduction. The system is integrated into a smart control system that can be controlled using a touchscreen located in the home or by an occupant's smartphone. The solar thermal hot air system operates in 2 general modes that depends on whether the home needs to be heated or cooled. In the wintertime, when the home needs to be heated, the panels draw in return air from the interior and can increase the air temperature by up to 60 degrees Fahrenheit. In this configuration, small inline fans connected to the panel system draw in air and propel it through insulated ductwork to a phase-changing material plenum, also known as a Pcm Plenum. The Pcm Plenum contains a hydrated salt which changes phase at 86 degrees Fahrenheit, the supply air temperature for the conditioned space. This PCM essentially works as a thermal battery for the home. It is insulated from the conditioned environment and can store up to 30 hours of heating for EnCORE once it is fully charged. In the spring and summertime, when the home needs to be cooled, the solar thermal hot air system functions in an entirely different configuration. Using a desiccant wheel dehumidifier, the solar thermal hot air system reduces the latent load of the cooling system by evaporating water vapor from the indoor environment, thereby reducing the humidity, saving energy, and increasing occupant comfort. In this configuration, return air from the house is passed over a desiccant wheel, which absorbs some of the moisture from the air. To regenerate the desiccant wheel so that it may remove more humidity from the indoor environment, the solar collector intakes outside air, which is heated from a solar thermal hot air collector, and passes it over the desiccant wheel to evaporate water from the wheel. The dehumidified return air is then sent to an air handler within the house and cooled by the house's heat pump. Next to the solar thermal unit is the passive solar glazing. These 3 large windows allow the sun to heat the home during the cold winter months, while control structures exist to block the sun during the hot summer days. To avoid unwanted conductive heat losses, these windows are all triple glazed. The windows also add great natural light for the home's occupants, thereby reducing lighting requirements and saving energy. On the roof there sits an 8.5 kilowatt solar array consisting of 108 thin film solar panels produced locally by First Solar in Perrysburg, Ohio. The thin film technology costed nearly 70% less than typical monocrystalline silicon panels when the building was constructed in 2011. On a good sunny day between late spring and early fall, this array collects about 30 kilowatt hours of energy. For reference, the average American household uses about 900 kilowatt hours per month, or 30 kilowatt hours a day. The photovoltaic system is a grid-tied photovoltaic system, which means that there is no on-site electrical battery storage. Instead, any excess electricity produced is put back into the grid, which turns the electrical meter backwards. In this configuration, the home can purchase electricity at nighttime when no electricity is being generated, thereby running the meter forward. But during the day, the home generally produces more energy than it uses, and the home sells back the energy to the grid and turns the electrical meter backward. This array is what makes it possible for the all-electric home to be net zero. Lastly, we have the solar thermal hot water system, which is also located on the roof. The primary method of water heating for the home is the house's indoor heat pump. The solar thermal hot water unit helps to heat the water to reduce the energy demand for this indoor heat pump. To do so, water is circulated in a closed-loop system between the home's hot water tank and the flat-plate solar collectors on the roof. This solar thermal hot water system is integrated into the heat pump controls and can reduce the water heating load by as much as 50 to 70% each year. On behalf of the Green Home Technology Center at Ohio State University, I want to thank you for watching. We hope that you find this presentation useful for your own home's design. If you have any questions or comments, feel free to reach out to our team at Ohio State via the provided contact information. Thanks again.